Hi everyone, welcome to this video on naming ionic compounds. So in this little lecture, we're going to go over a couple things to start with just to make sure we're all on the same page to begin. And then we'll cover a set of questions that you can ask yourself when you're looking at the formula for an ionic compound in order to determine its name. Okay, so the two things that I want to start with before we jump into the actual naming steps. One, you're going to need a periodic table, and there are a couple things that you should be able to feel comfortable with on the periodic table before we start. So one, you should be able to look at a periodic table and figure out what the charge for each any given element or atom is going to be. And that's going to have to do with how many valence electrons these different groups have. So remember that you can figure out the number of valence electrons by just going across the top. Groups 1 and 2 have 1 and 2 valence electrons respectively. Group 13, 14, 15 has 3, 4, 5 valence electrons, etc., all the way across to 8 valence electrons for the noble gases. And then when we're thinking about what sort of cation or anion these things are going to form, remember that anything that has less than 4 valence electrons is going to find it easiest to just drop their electrons that they have, or in reality, they're donating those electrons to other atoms. So group 1, they're going to lose their 1 valence electron and form a +1 ion. Similar thing for group 2, they're going to drop their 2 valence electrons and form +2 ions. All the way over here, for 3 valence electrons, they're going to drop all 3 valence electrons and form +3 ions. And remember, these are all going to be called cations. Cations are positive. So cations are positive. We're not going to really deal with the 4 valence electron groups here. They could either gain 4 or lose 4. They're not going to typically be involved in ionic compounds, though, so we're not going to worry about them. Noble gases also don't really tend to do much because they already have a full outer shell. But for this group that has 7 valence electrons, they're going to find it easiest to gain 1 extra electron to reach 8, so they'll form -1 ions. Group 16 with 6 valence electrons will gain 2 valence electrons, or will gain 2 electrons to form ions that are -2. And then for the group that has 5 valence electrons, they'll gain 3 electrons to form 8, and they'll form -3 ions. And these ones are going to be called anions, which are negative. And then the last piece that I want to talk about is that remember that we are talking about the D block here being called transition metals. So you need to be on the lookout for anything that falls in the transition metal category. And actually, so this stair-step line that we've got in red here is going to divide up our metals, which are on the left, and our nonmetals that are on the right. And we have this funny little chunk here. So this bit right here, we call them the post-transition metals because they come after these transition metals. But when we're naming, a lot of times you might need to give Roman numerals to these guys as well. So for something like copper or nickel, cobalt or nickel or copper, remember that we'll get into this in the next slide, but you're going to add Roman numerals. But also if you see something like tin or lead or gallium, these need Roman numerals as well. So for our purposes, we're just going to lump together everything that's to the left of the stair-step line, but to the right of this line right here. So really the only cations that don't need Roman numerals are the first and second groups, which is kind of a pain, but that's just the life we're living in chemistry these days. Okay, and then the second piece of information that you'll need is going to come on this polyatomic ion chart, which can be found on the back of your periodic tables. And this chart is going to give you the name of the polyatomic ion, its formula, and also its charge. And you can see the charge at the top of the table. So these all have a -1 charge. These all have a -2 charge. And you can also see it in the formula itself. So a single minus sign or a single positive sign means it's -1 or +1, respectively. But you can see these ones have a -2 and these ones have a -3. So you can also see the charge in that way. Okay, so when we're thinking about how to name ionic compounds, just one thing to when you're looking at the formula, you'll see that it's divided up into two pieces. So one piece is going to be the cation piece, or the positive charge piece, and one part is going to be the anion, or the negative charge piece. And there's, I guess, a series of questions that you can ask yourself for both the cation and then the anion as well. So let's start with the cation bit. So the first thing that you should ask yourself is it monoatomic or is it polyatomic? Or polyatomic. I did not spell that correctly whatsoever. I should say monoatomic or polyatomic. So the vast majority of cations are going to be monoatomic. What is happening? Sorry about that. Polyatomic. The vast majority of cations are going to be monoatomic, which means it's just an element on the periodic table. Remember, the polyatomic ones are ones that have more than one atom sort of smushed together. So you can see cyanide has carbon and nitrogen. Hypochlorite has chloride or chlorine and oxygen. Sulfate has sulfur and oxygen. So for cations in particular, remember those are going to be positively charged, and really the only cation that's going to be polyatomic that is at all common is going to be ammonium, or NH4. So you can see that there's two atoms, nitrogen and hydrogen, and if it's polyatomic, then your job is done. You just write the name of the polyatomic ion. Name of polyatomic cation. And like I said, that's almost always going to be ammonium if it is a polyatomic ion. If it's monoatomic, you're going to write the name of the element, or the name of the metal, I guess is another way to say it. Name of the element, but you have to ask yourself one more question. It's going to be the name of the element, but if it's a transition metal or a post-transition metal, then it needs Roman numerals. So transition metal, if yes, then we need Roman numerals. If not, then you're done just by writing the name of the element itself. Okay, so there's that. And then for the anion, we're going to ask ourselves the same question. Is it monoatomic or polyatomic? And again, if it's polyatomic, we write the name of the polyatomic ion. And then we're done. Polyatomic anion. And that's it. If it's monoatomic, then we're going to write the name of the element. This is a name of element, but we're going to add an IDE ending with "ide" ending. So this kind of stuff I think all makes more sense when you do practice rather than just talking about the theoretical rules. So we'll go on to the next page and do some practice problems together. Okay, so when we look at this first example, we've got two parts, like I said. There's the cation, Mg, and the anion, Br. And when you look at these, you can see that there's only two, like there's one ion for the cation and one ion for the anion. So there's no polyatomic situation whatsoever. It's all monoatomic. So Mg can be found right here, and it's magnesium. And it's not a transition metal or a post-transition metal, so we don't need any Roman numerals. And when we look at the second part, it's bromine, which is right here. And again, just a monoatomic ion, so we just switch it to an IDE ending. So instead of bromine, it becomes bromide. And that's it. That's all we have to do. That's the easiest case scenario, and I don't think there are any other ones that are quite that simple in this example list. So hopefully you at least feel good with if it's just two monoatomic ions, it's just the name of the element. I don't know why I keep skipping ahead. Just the name of the element and the name of the second element with that "ide" ending. Okay, so let's look at another example. So in the second one, we've got our cation right here, Cr, and our anion right here, Se. So Cr is right here, chromium, and so we'll write that, chromium. But you'll see that it falls in a transition metal block, so we're going to need to put Roman numerals after the name. So we'll do that last. We're just going to leave that step for the end, and we'll finish off with the ending for our anion. So Se is right here. Selenium. This is a weird one. It's going to turn into selenide. Don't worry so much about that's a super weird one. We'll give you either friendlier examples or more like the normal weird ones like phosphide or oxide. Okay, so we've got both parts named, the cation and the anion, but the last step is that we need to figure out what goes inside for our Roman numerals. And the way to do that is to figure out what the charge is for the anion. So Se is in this block right here, and we know that this block has 6 valence electrons, and in order to become stable, it's going to gain 2 electrons. So it's going to form -2 ions. So therefore, we know that selenium is bringing a -2 charge to the table, as it were, for this ionic compound. There are no subscripts. It's just one single selenium ion and one single chromium ion. And so since the selenium is bringing -2, we know that our chromium has to be bringing a +2 charge, because altogether, this whole ionic compound needs to be neutral or have a charge of negative. So we should be able to add together +2 and -2 and get 0. Since our Cr is bringing +2 to the table, then we're going to put 2 inside of our parentheses for our Roman numerals. So it's chromium 2 selenide. Okay, we'll get more practice. We'll get a lot more practice with Roman numerals for the rest of these examples. Our next piece is iron. So iron is our cation, and then we've got a polyatomic ion for the anion. So iron, Fe, we can find it right here on the periodic table. Again, it's in the transition metal group, so we're going to write iron, leave space for our Roman numerals, and then we need to name the anion. Since it's a polyatomic ion, we go over here to our chart and have to find the one that says NO3. And I'm realizing as I look at this that I covered it up a little bit accidentally with my periodic table. So if you were able to read this, it would say nitrate, and that should read NO3. So NO3 is nitrate, so we would write nitrate right there. And that's it. That's all we have to do. Since it's a polyatomic ion, we just write the name of the polyatomic ion. Okay, and then our last step is to figure out what goes inside of the parentheses for our Roman numerals. Nitrate is, and again, we're going to look at the anion first in order to determine that. Nitrate is NO3, and it's a 1- polyatomic ion. But the catch is that because of this 3 here, that means that there are 3 of them that are present. So we have NO3, NO3, NO3. There are 3 nitrates, and each and every one of them has a negative charge, a -1 charge. So if you add all of these up, it's -1, -1, -1 for a total charge of -3. So all of these nitrates together have a -3 charge, and that means that our iron, all by itself, there's only one of them, has to have a +3 charge, +3. So we're going to put a 3 in the parentheses, iron 3 nitrate. Let's try another example. So this one again, we've got no polyatomic ions. We've just got a monoatomic cation and a monoatomic anion. And when we look at the symbols, we've got copper. And again, I feel like your heart sinks a little bit because it's in the transition metal block. It's a rough life, but it's what we're living right now. Copper, and we're going to have Roman numerals, and then the P is for phosphorus. And so we're just going to change it to an ID ending, and it's phosphide. So it's copper something phosphide. Phosphorus has 5 valence electrons, and so it's going to form a -3 anion. So we know that the phosphorus is bringing a -3 to the table. So in order to figure out what the copper is bringing to the table, first we have to think about the fact that there are 3 of them. So when we're thinking about like what this looks like, it's 3 coppers and 1 phosphorus. The phosphorus is, the phosphorus is -3, which means that all of our copper has to equal altogether +3, which means that each individual copper is going to be +1. So if each copper is +1, then altogether it's going to be +3, and then the +3 and the -3 will equal out. We'll get a neutral charge. So each individual copper is just going to be +1, so we put a 1 in the parentheses. Okay, let's keep going. So for this one, our cation is here, our anion is here. So we've hit the jackpot. We've got our 1 polyatomic cation, which is ammonium. So to start off our name, we're just going to write ammonium. I feel like this point is really exciting. Anything that's not in the transition metal group, I get really excited. And then Cl is chlorine. So we just change it to the ID ending, and it's going to be chloride, ammonium chloride. Okay, let's keep going. So we've got, again, 2 monoatomic ions. Ga is gallium, and As is arsenic. So gallium is in this post-transition metal group, so it is going to need some Roman numerals. So we'll leave the parentheses there. And then arsenide. Arsenide, yeah, I think that's right. Arsenide. Yeah, I'm just going to say that's right, arsenide. Okay, so gallium needs Roman numerals, and to figure out how many, let's look at arsenic, which again is -3. And so there's just 1 -3 arsenic, and so gallium must be +3. So we'll put the 3 in Roman numerals. We've got 4 more, and if you look at all of the rest of these, they all have polyatomic anions. So all of the rest of our anion names are going to be coming from this polyatomic table, and some of them are going to need Roman numerals. So this one is Pb for a cation, which is right here. It's lead. Oh, man, I'm having a lot of trouble with my slide management. So we'll write lead. And again, it's in this weird post-transition metal section, so we're going to leave space for parentheses. And then SO4, it's going to be sulfate right here. So you can see SO4 corresponds to sulfate. So to end it, we just write sulfate. So when we're thinking about what is going to come in the Roman numerals, we've got sulfate, but we've got 2 of them. And each sulfate ion is -2 for its charge. So we've got -2, but there are 2 of them. So altogether, we have a -4 situation for our anion. The lead is single, there's just one of them. So it has to have a +4 charge to balance out the -4 charge. So we're going to write a 4 inside of the parentheses for our Roman numerals. Okay, so this next one, our cation is beryllium, which is right here. And at this point, I'm really excited because it's not in the transition metal group. So we can just write beryllium. And then ClO3 is our anion, and that's right here, chlorate, ClO3. So beryllium chlorate, and that's going to be it. Two more. Mn is our cation for this one, and unfortunately, it's in the transition metal group. So we'll write manganese and leave room. And then SO3 is our polyatomic ion. So in our chart, SO3 is right here, and we can see that that is sulfite. So we write sulfite. And then we have to figure out what goes inside of the Roman numerals. So here, sulfite is again a -2 ion, but when we look here, we can see that there are 3 of them. So we've got SO3, SO3, SO3. Each one of them is -2, -2, -2, -2. So altogether, our whole negative charge is going to be -2 plus -2 plus -2, which is -6 altogether. So our negative charge is -6. On our positive side, we've got Mn, and we've got 2 of them, Mn, Mn. So altogether, they need to equal +6 to balance out the charge, which means that each Mn, each manganese ion, is going to be +3. So if this one was +3 and this one was +3, then altogether they would equal +6. So we're going to write 3 because each individual manganese ion is going to be a +3 charge. So manganese 3 sulfite. Okay, and then our last one is aluminum for our anion. And when we find aluminum in the periodic table, it's right here. So aluminum is always going to be +3, so it doesn't have different number of valence electrons it can have, so we don't actually need any Roman numerals, but it does come to the left. We'll just start by writing it. Aluminum. When you guys are taking a test on this, it'll be really clear. Pretty much all of the transition metals or all of the ones that you'll need Roman numerals for will be transition metals. They won't be in this weird, like, awkward zone of maybe maybe they have different number of charges. So I wouldn't worry too much about that. For aluminum, it's always going to be +3. We don't actually need to write anything in parentheses. And then its anion is Cn, which is cyanide right here. So it's just going to be aluminum cyanide. And that would be it. Okay, so I hope this video with naming ionic compounds was helpful. There will be another one right after this that's about writing the formula for ionic compounds based on the name, so going in the other direction. And I will see you guys soon.